Let's look at the solution for question number 2. In the sum, you're told that there is a 10 cm pipe that delivers water to a 3 cm nozzle. You're given the flow rate as 25 liters per second. Now, looking at the sum, intuitively we will know that if we have a nozzle which constrains the velocity, there is a momentum effect because the water is being caused to converge. Because of this convergence, there is a momentum effect and there is a tendency for the nozzle to shoot out. So it is important that in this case we have flanges and flange bolts between the pipe and the nozzle to hold on to the nozzle. So what we are going to do is do a calculation of these forces. Now on the right hand side here, you see the control volume being drawn, and in particular we are focusing only on the nozzle. Right. You can also draw a little sketch, simple sketch, reasonably accurate, to represent the control volume and the nozzle in question. It's very important that you show the sketch. This will help you focus on the question and the important forces, especially the momentum force. Now let's get back to continuing the solution. What we are required to do now is to find, using a streamline from 1 to 2, the pipe outlet to the nozzle outlet. So the pipe outlet is actually the nozzle inlet to the nozzle outlet. We know the area of the pipe and the inlet to the nozzle. We know the velocity flow rate, volumetric flow rate, sorry. We can calculate using the volumetric flow rate, 0.025 cubic meters per second, divided by the area at the pipe. Okay, this is done separately here to illustrate, and we get the velocity at the nozzle inlet or the pipe outlet as 3.2 meters per second. We also now do the same thing to calculate the velocity at the nozzle outlet, because by continuity A2 V2 is equal to A1 V1, so we calculate V2, same volume flow rate, area reduced, higher velocity. Okay, we need these two velocities, V1 and V2, to do our calculation using the Bernoulli's equation, which is seen here. V1, V2, excuse me, and Z1 and Z2, for all intents and purposes, are the same because the nozzle is horizontal. Our pressure P1 has to be calculated, and we know the pressure P2 is in fact atmospheric pressure, which is 0 gauge. Let's now zoom in on the solution for calculating P1. As we said earlier, we know V1, we know V2, Z1 and Z2 are equal, so they cancel out. This is given in the next line, and we solve for the pressure P1. Remember, the pressure P1 is 620 kilopascals gauge, because we assumed that P P1 was, P2 was atmospheric pressure. So the value of P1 is in fact 620 kilopascals gauge. Okay, this is stated explicitly in the question. We now do part C, where we have to calculate the force on the bolts. If you look, I have taken 2 bolts as an example. It could be a series of 6 bolts, so each one will be divided by 6. So for all intents and purposes, you can just call it a minus F. Notice minus F because in the free body diagram, it acts in the opposite direction. Pressure P1 times A acts in the positive X direction. Mass flow rate V2 leaving minus V1. So this gives us F is equal to P1 A1 minus the mass flow rate V2 minus V1. Now substituting into the values into that momentum equation, we will get the answer of 4.067 kilonewtons. This ends the solution.